web series Unwrapping Docker. We will continue where we left. So let's quickly jump where we have left. So this is our slide. Um, what is Docker? But wait, before we head out to the Docker, we need to understand some basic fundamentals about the virtualization. So the types of virtualization. The first is OS level virtualization. Then we have a application level virtualization. Then we have a kernel level virtualization. So what is OS level virtualization? So whenever we install our hypervisor as an operating system, that's known to be as operating system level virtualization. In our case, let's say we install Hyper-V or maybe VMware ESXi or maybe Citrix. So there are a lot of hypervisor which can be installed as a operating system. So that particular type is known to be as OS level virtualization. Then we have a application level virtualization. So imagine we already have operating system. Maybe it could be a Windows, Mac, iOS, Mac, or maybe Linux. On top of operating system, we install some virtualization software like VMware vSphere, VMware SphereX, VirtualBox, UTM, and there are many, maybe parallel. So there are a lot of application that can be installed on top of your operating system that known to be as a application level virtualization. Then we have a kernel level virtualization. So in kernel level virtualization, we share a base level kernel. In above previous example, on both example we install or create VM, and on top of that we install operating system. But in kernel level virtualization, we do not install operating system, neither kernel. In both above cases, we have to install operating system alongside with its kernel. So kernel level virtualization known to be as another name with containerization, or vice versa. You can say kernel level virtualization is equal to containerization. So in both meaning you are saying the right thing. So all in all, kernel level virtualization, what happens, or what is kernel level virtualization? In containerization, we don't whenever we spawn up any Docker container, we do not install our Linux kernel or maybe kernel. If we are creating containers of Debian, or maybe we are creating containers of Windows, so in both cases the container is not going to install the kernel. It utilizes the base machine kernel. What it does, it install required libraries and dependency which actually required to run specific distribution. Let's say if you run Ubuntu container, so it won't install the kernel, but it will install the required libraries and software packages, utilities that gonna be run at Ubuntu level. And what it will does, it will always share the base machine kernel. So that is why we called it as a kernel level virtualization. So moving to our next topic, what is Docker? So Docker is an open source project that enables you to provide seamless environment in staging and production. Let's say what normally happens, one of your developer are doing development on their local machine, application works well, but when you deploy that the same code on production, it won't work. It start breaking. Maybe you start to having some dependencies issues, maybe instability in an environment or inconsistency in environment. So Docker gives consistency in across environment. Like if you build or deploy your code on your local machine, staging or production, it will remain same. Docker also provides ability to run multiple isolated OS on a single host. Let's say one of your application runs on CentOS 5.6, or in other words, one of your application requires PHP 5.7, and on the very next you have another application that requires PHP 7.2, and there are some many other applications that requires different versions of your softwares. So in that case, what you will do, will you gonna spin up multiple OS operating system or multiple machine, multiple virtual machines? No. The solution is Docker. uh, you can run all the operating systems in your single machine in parallel. So you could run Ubuntu, you could run CentOS, and you could run Alpine or Windows in a single host. That Docker actually enables you to run multiple operating system in isolated environments. And noted to be one thing noted to be here is every single operating system is isolated from each other. Docker enables you to utilize the maximum resources from your hardware. Imagine you have a machine with 16 GB of RAM, and uh, you run application on your machine which consume 1 GB of RAM. So rest of the 15 GB is wasting on your hardware. Whereas Docker enables you to run or utilize your maximum hardware. You could run multiple applications on the same hardware, so that will actually utilize the maximum resources from your hardware. In simple words, whenever someone asks what is Docker, so I always says Docker is nothing just a Linux or Unix process that runs on top of OS with resource isolation, or Docker is nothing just a Unix process that runs in isolated environment. If you run multiple containers, so that means you are running multiple Linux processes, but all of them are separated from each other. How Docker does that? So that's the question whenever you saying Docker is nothing just a unique process and that runs in isolated environment. So Docker uses a couple of features that Linux offers. The first feature is C groups. C group is also known as control groups that actually enables Docker to access kernel, CPU, memory, and other resources, and that actually gives you ability to isolate all the resources or all the requests from each other. Let's understand the Docker architecture. So Docker on your machine is, at the time of writing, split into two parts: a daemon with a RESTful API and the client that talks to the daemon. So the Docker, whenever you install a Docker, that means you are installing a server that actually expose a RESTful API. And whenever you are interacting with your Docker host with Docker CLI tool, like if you execute Docker PS, that means you are interacting with a web server that actually expose with a RESTful API. So all in all, Docker architecture is a client server model. So daemon is the server and CLI tool is your client. Whenever you invoke the Docker client to get the information or give instruction to the daemon is a server that receives a request and returns a response from the client using HTTP protocol. That's we just discussed. So the daemon, it's actually a web server that returns and receive request in the form of HTTP request. So let's understand in a deep. So we have a, let me just zoom out. Okay, so this is our architecture. So this is our Docker client, this is our host machine, by the way, and this is our internet. We are not discussing this part at the moment. What we are doing, we are discussing this part at the moment. So this is your host, and on the host you have running Docker daemon. So whenever you are interact, and this is your Docker client, so whenever your Docker client invoke or give or request any information from the daemon, it sends a HTTP request to a Docker daemon. And then Docker daemon, which actually a web server, or you can say a server that expose or work with a RESTful API, it returns or receives the response in the form of HTTP request. So in other components, there are some other components that also interact with the Docker daemon. So the one component is client, another component is Docker daemon. So there are another component which is Docker hub. You can say a Docker registry. So it could be a private registry, or it could be a Docker hub, which is a public repo. And there are some other public Docker registry as well. What is Docker registry? Docker registry is just a you can say place where you can put your Docker images. We will discuss later what are the Docker images in the detail. So this is our Docker architecture. So we make client, whenever client make request to either daemon or to the registry, all those requests are in a form of HTTP. So it sends the restful, like you can say it creates a restful request and send to the daemon or the registry. And registry, the same way they send in a restful manner or using the HTTP protocol. So moving to our next topic. So we covered this item as well, now we need to move to our next item, Docker internals. I'm keeping this video till the Docker in architecture. In the next video we will cover Docker internals. If you are not if you didn't subscribe our YouTube channel, so please do subscribe and also share and like this video. Thank you for watching this video. I hope you will like it, and please stay tuned with us for the next videos.